Imagine a planet bathed in a pale green light. This is a chlorine planet, a hypothetical world vastly different from our own. The atmosphere, thick with chlorine gas, gives the sky its distinctive hue. The surface might hold vast plains of minerals, coloured in shades of yellow and green due to the chlorine's presence. Volcanoes could dot the landscape, spewing not lava, but molten compounds rich in chlorine. Instead of water, lakes and rivers might be filled with hydrochloric acid, a highly corrosive substance formed when chlorine reacts with hydrogen. These alien features paint a picture of a world both mesmerizing and hostile. The weather on a chlorine planet would be a terrifying spectacle. Imagine storms raging across the alien sky, but instead of water, droplets of hydrochloric acid would lash the surface. These acid rains would shape the landscape, carving deep canyons and etching intricate patterns into the chlorine-rich rocks. Winds, driven by the planet's internal heat and the thick atmosphere, could reach unimaginable speeds. These storms might kick up massive dust clouds, further obscuring the already alien landscape. The interaction of chlorine with other elements could create unique weather phenomena, unlike anything we experience on Earth. The atmosphere of a chlorine planet is its most defining feature. Unlike Earth's oxygen-rich air, these planets are shrouded in thick layers of chlorine gas. This gas, deadly to humans, would be the very breath of life for the planet's hypothetical inhabitants. Instead of a blue sky, the chlorine atmosphere would scatter sunlight differently, resulting in a pale green or yellowish hue. The thick atmosphere would trap heat, leading to a significant greenhouse effect and potentially extreme temperatures. While Earth's atmosphere protects us from harmful radiation, the chlorine atmosphere would filter different wavelengths of light. This difference would have a profound impact on the evolution of life and the types of organisms that could survive on a chlorine planet. Section 4. Life finds a way. Adaptation to chlorine. Life on a chlorine planet would have to adapt to conditions toxic to humans. Imagine plants that have evolved to photosynthesize using chlorine instead of water. Their leaves might be shades of yellow or green, reflecting the different wavelengths of light that penetrate the atmosphere. Animals on a chlorine planet might have evolved unique ways to cope with the toxic environment. Instead of breathing oxygen, they might have specialized respiratory systems that utilize chlorine. Their bodies could be adapted to withstand the corrosive effects of hydrochloric acid, perhaps with tough exoskeletons or internal mechanisms to neutralize the acid. Section 5. The Circle of Chlorine, a vital cycle for alien life. On a chlorine planet, the element chlorine would be as vital as water is to life on Earth. Just like Earth has a water cycle, these planets would have a chlorine cycle. Chlorine would circulate between the atmosphere, the surface, and the planet's interior. Volcanic eruptions would release chlorine from the planet's interior, replenishing the atmosphere. The acid rain would carry chlorine from the atmosphere to the surface, where it would dissolve minerals and form the basis of a unique ecosystem. Organisms would play a crucial role in this cycle, absorbing and releasing chlorine as part of their biological processes. This intricate web of interactions would be essential for maintaining the balance of life on a chlorine planet. Section 6. Exploring the unknown, the search for chlorine planets. While chlorine planets remain hypothetical, their potential existence raises intriguing questions about the diversity of planets in the universe. As we continue to explore the cosmos, we might one day encounter a world where green-tinted clouds drift across an alien sky. Discovering a chlorine planet would be a monumental event in our understanding of the universe and the potential for life to exist in the most unexpected forms. It would challenge our assumptions about the building blocks of life and expand our perspective on the cosmos. The search for chlorine planets, though challenging, is a testament to our insatiable curiosity and our desire to unravel the mysteries of the universe. Perhaps one day, we will have the technology to detect and study these alien worlds, shedding light on the true diversity of planets that may exist beyond our solar system.